Hello friends, I'm your maths faculty for 10th standard from QLS Academy. In this session, we are going to begin with the topic polynomials. Let us proceed towards the learning part now, which I'm sure is going to be fun for you. So friends, in class 9th, you have studied polynomials in one variable and their degrees, that is, the degrees of the polynomial. Recall that if p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial p of x. I repeat, if p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial p of x. For example, 4x plus 2 is a polynomial in the variable x of degree 1. 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. 5x cube minus 4x square plus x minus 2 is a polynomial in the variable x of degree 3. 7u raised to the power 6 minus 3 by 2u raised to the power 4 plus 4u square plus u is a polynomial in the variable u of degree 6. Expressions like 1 upon 1 minus x, root x plus 2, 1 upon x square plus 2x plus 3 etc. are not polynomials. A polynomial of degree 1 is called linear polynomial. For example, 2x minus 3, root 3, x plus 5, y plus root 2, x minus 2 by 11, 3z plus 4, 2 by 3 u plus 1 etc. are all linear polynomials. Polynomials such as 2x plus 5 minus x square, x cube plus 1 etc. are not linear polynomials. A polynomial of degree 2 is called a quadratic polynomial. The name quadratic has been derived from the word quadrate, which means square. For example, y square minus 2, 2 minus x square plus root 3x, u by 3 minus 2u square plus 5, or root 5 v square minus 2 by 3v, 4z square plus 1 by 7 etc. More generally, any quadratic polynomial in x is of the form ax square plus bx plus c, where a, b and c are real numbers and a is not equal to 0. Remember, a is not equal to 0. And a polynomial of degree 3 is called a cubic polynomial. For example, x cube minus 2, x square plus x cube, 3x cube minus 2x square plus x minus 1 etc. In fact, the most general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers and a is again not equal to 0. हम हर बार देख रहे that the coefficient of x cube a cannot be equal to 0. Why so? This is because अगर a ही 0 हो गया तो a into x cube भी 0 हो जाएगा, because 0 into anything is equal to 0. और अगर ये टर्म 0 हो गई तो हमारा पॉलिनोमियल क्यूबिक रहा ही नहीं, सिंस सबसे इम्पोर्टेंट और डिटरमाइनिंग टर्म जिसमें x क्यूब था वो तो है ही नहीं पॉलिनोमियल में. Now consider the polynomial p of x equal to x square minus 3x minus 4. Then on putting x equal to 2 in the polynomial, we get p of 2 is equal to 22 minus 3 into 2 minus 4, that is equal to minus 6. The value minus 6 obtained by replacing x by 2 in x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x equal to 2. Similarly, p of 0 is the value of p of x at x equal to 0, which is minus 4. So if p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x equal to k and is denoted by p of k. Now guys, you have already studied in class 9th how to find the zeros of a linear polynomial. For example, if k is a zero of p of x is equal to 2x plus 3, then p of k is equal to 0 gives us 2k plus 3 equal to 0, that is k equal to minus 3 by 2. In general, if k is a 0 of p of x is equal to ax plus b, then p of k is equal to ak plus b is equal to 0, that is k is equal to minus b by a. I repeat, ak plus b is equal to 0 gives us k is equal to minus b by a. So the 0 of the linear polynomial ax plus b is minus b by a, which is minus of constant term upon coefficient of x. Thus, the 0 of a linear polynomial is related to its coefficients. You know that a real number k is a 0 of the polynomial p of x if p of k is equal to 0. But why are the zeros of a polynomial so important? To answer this, first we will see the geometrical representations of linear and quadratic polynomials and the geometrical meaning of their zeros. Consider first a linear polynomial ax plus b, where a is not equal to 0. You have studied in class 9th that the graph of y is equal to ax plus b is a straight line. I repeat, the graph of y is equal to ax plus b is a straight line. For example, the graph of y is equal to 2x plus 3 is a straight line passing through the points minus 2, minus 1 and 2, 7. The graph of y is equal to 2x plus 3 intersects the x-axis midway between minus 1 and minus 2, that is x equal to minus 1 and x is equal to minus 2, that is at the point minus 3 by 2, 0. You also know that the 0 of 2x plus 3 is minus 3 by 2. Thus, the 0 of the polynomial 2x plus 3 is the x coordinate of the point where the graph of y is equal to 2x plus 3 intersects the x-axis. In general, for a linear polynomial ax plus b where a is not equal to 0, the graph of y is equal to ax plus b is a straight line which intersects the x-axis at exactly one point. I repeat, exactly one point, namely minus b by a, 0. Therefore, the linear polynomial ax plus b a not equal to 0 has exactly 1, 0, namely the x coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. Now let us look for the geometrical meaning of a 0 of a quadratic polynomial. Consider the quadratic polynomial x square minus 3x minus 4. Let us see what the graph of y is equal to x square minus 3x minus 4 looks like. We list a few values of y is equal to x square minus 3x minus 4 corresponding to a few values of x, and then locate the points listed on a graph paper and draw the graph. We get a parabola opening upwards. In fact, for any quadratic polynomial ax square plus bx plus c where a is not equal to 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two shapes, either open upwards or open downwards, depending whether a is greater than 0 or a is less than 0. These curves are called parabolas. Also, minus 1 and 4 are zeros of the quadratic polynomial x square minus 3x minus 4. क्योंकि x axis को parabola इन दो points पे intersect कर रहा है. y is equal to x square minus 3x minus 4 intersects the x axis. This fact is true for any quadratic polynomial, that is, the zeros of a quadratic polynomial. Ax square plus bx plus c, a not equal to 0, are precisely the x coordinates of the points where the parabola representing y is equal to ax square plus bx plus c intersects the x-axis. So friends, this is it for this session. You just got introduced to the topic polynomials, quadratic polynomials and cubic polynomials in particular. I hope you had fun learning. If you have any queries, you can visit the link following the video. Thank you.